let us start the discussion on the next important property of TCP, that is error control. By virtue of this error control property, we talked in the beginning, we discussed that TCP ensures reliable transmission. This property will show us with examples that how TCP ensures reliable transmission. There are three types of cases dealt by TCP while doing this error control. One is corrupted segment, another is lost segment, finally is lost acknowledgement. Now, these first two types, that is corrupted or lost segment, TCP has a nice way to deal with them. What is that? They deal with them, TCP deals with these two types in a similar manner. Let us see that. So basically we have, instead of three, we have two types of working to understand. Let us see what it is. This is my sender machine running my sender TCP process. This is my receiver machine running my receiving TCP process. Now we are sending, say, one after the other, three segments. By the side of each segment there is a green clock shown, that is basically depicting that with each segment there is a timeout period associated. What is that timeout period? That is nothing but retransmission timer. These green ones, basically they are showing my retransmission timeout period. What is the meaning of it? A segment, once it is transmitted, my retransmission timer starts working. And what is it for? This is basically for, it will wait for a certain time period. There is ways to calculate it, we will discuss it later on, but it will start waiting for a certain time period. By that time, if the acknowledgement does not come back to the sending TCP, the segment is considered as not being transmitted. It gets retransmitted, as simple as that. So retransmission timer's responsibility is to keep on checking the timeout period. If the acknowledgement does not come back within that time period, segment must be retransmitted. Why must be? Because TCP has to ensure reliable transmission. Each and every byte of data must be received by the receiver. So now, what is this example showing? There are three segments shown, sent with sequence numbers 1201, 1401 and 1601. Each it automatically tells you each is having 200 bytes data. Now, segment 1 has been sent, timer started working, the acknowledgement came back within my timeout period as it shows OK. Fine. Segment 2 was transmitted, the timeout, before the timeout happened, my acknowledgement has come back, it is also showing OK. My segment 3 was transmitted, but receiver has identified, it was received by the receiver, but receiver has identified that the segment 3 is corrupted. The query must come that, sir, how does the receiver identify the segment is corrupted? We have ways to identify it at the receiver. When we learn the segment structure of TCP, we will discuss about it. For the time being, let us understand, or let us take it for granted that the segment 3 has been corrupted, it has been understood by the receiver. Now, you tell me, you send me a message, I understand the message has been tampered with, or it has not been it is a corrupted message. What should I tell you? I should tell you that you must retransmit me the message because I got it in a tampered or corrupted format. How does receiving TCP do that? Receiving TCP does not send the acknowledgement. There is no negative acknowledgement in TCP. There is only one type of acknowledgement. If I receive it properly, I send an acknowledgement. If I don't receive it properly, I do not acknowledge. As simple as that. So, segment 3 got corrupted, myself being the receiving TCP, I will not acknowledge it. I did not. Now what happens at the sending end? I sent the segment, sending TCP, and the clock started ticking. It is taking count or keeping a record of the retransmission timeout period. I did not, the receiving TCP did not send the acknowledgement. What will happen? This timer will go off. It will go past the timeout period. Acknowledgement did not come. The segment 3 gets retransmitted. It has been received properly now, sends the acknowledgement, receiver sends the acknowledgement, it comes back to the sender within the timeout period, okay. Query comes, or query should come from your side that, sir, if it had got corrupted again, what would have happened? TCP, sending TCP has to ensure all segments have been received by receiving TCP in a proper form, in non-corrupted form. Until and unless it is being received properly here, it will keep on retransmitting it. The timer will keep on getting timeout and it will keep on getting retransmitted. How long? Until and unless that segment has been received properly. Now, that's something I hope that hits a chord, that sometimes when you try to access some web pages and it gets delayed, we have a tendency of saying, the internet connection is so poor, so bad. But actually so many things are happening at the background. Accessing web page means you are trying to use the HTTP protocol. HTTP as the background or as the transport layer support, whose help does it take? It takes the help of TCP, because HTTP requires reliable transmission. Who will give the support of reliable transmission from transport layer? TCP only. TCP has so much of technical complexity involved. Next part, next type of error control operation to be done. This was corrupted segment, and next one is lost segment. Same example let us discuss. There are 3 segments to be sent across, sequence number 1201, 1401, 1601, each having 200 bytes. Segment 1, 2, 3 all have been sent across. Each of them, they are having their retransmission timer activated as soon as it has been transmitted. Now, one point of thing which we should consider, say segment 2, it has been received here. What is the acknowledgement to be sent across? We discussed in the first segment of discussion, if you remember. Sequence 1 is having sequence number being 1401. For segment 2, it is of 200 bytes. That means it goes from 1401 to 1600. It has come here. Acknowledgement is the number which the receiver expects to receive next. So it has received till 1600. What will be my acknowledgement? 1601. Very simple. Now, segment 3 has been sent. In this example, as it is shown in this diagram, segment 3 gets lost midway. How come it gets lost, sir? It can get lost anyway. There are n number of routers from my machine in Kolkata to the California machine I am trying to connect. There are n number of routers, switches, midway. Anywhere, because of congestion, data can get dropped. TCP has to ensure that no data is lost in the transmission, be the machines are in Kolkata and California. So my segment 3 got lost. What will happen? Segment 3, once it was sent across, my retransmission timer started working. It got lost. That means segment 3 was not received by the receiver. What will happen? Will receiver acknowledge it? No, it did not receive the segment. Why will it acknowledge? So automatically receiver not receiving the segment, it did not acknowledge. At the sender end, my retransmission timer kept on working, ticking, but it actually hit the timeout period. Acknowledgement did not come back. Now what happens? Segment 3 gets retransmitted. Once it is received properly, it gets acknowledged. If the acknowledgement comes back within timeout period, it's fine. Again the query will come, sir, how many times does it get retransmitted? As long as it gets transmitted and received properly by receiver, as well as the acknowledgement comes in proper time within timeout period. Till then it will keep on retransmitting it until and unless the receiver receives it properly. So this was the second case. I hope by this time we have understood corrupted segment and lost segment, they are dealt with in exactly the same manner by TCP. The corrupted or the lost segment must be retransmitted by the sending TCP. Last part, that is lost acknowledgement. Segment is a message, a portion of a message. If it can get lost, acknowledgement is also a message, right? So why not an acknowledgement can get lost? Because the acknowledgement in our example is also traveling from California back to Kolkata. If a message traveling from Kolkata to California get corrupted or lost midway, a portion of the message traveling from California to Kolkata can also get lost. Isn't it so? So we have to deal with this case also, lost acknowledgement. Now let us remember that single point we discussed at the first phase of the lecture. What was it? Acknowledgement of TCP is cumulative in nature. We will understand it thoroughly here. What is it? The sender TCP, the same example, it has sent 3 segments with sequence numbers 1201, 1401, 1601, each consisting of 200 bytes. The numbers tell me that. Now, first segment acknowledgement will be 1401, I hope we understand. Second segment acknowledgement will be 1601. Third segment acknowledgement will be 1801. Very simple calculations. First segment acknowledgement, say, comes back within timeout period, as it is shows. Okay, great. Second segment's acknowledgement gets lost. See here, acknowledgement 1601, that message gets lost. First thing which should strike your mind, sir, in this case there may be a retransmission scenario which is redundant because I received it properly. Let us take the example a bit further. Third segment's sequence number was 1600 with 200 bytes. My acknowledgement should have been 1800. Now see here, this acknowledgement 1800 is received by the sender within timeout period of third segment as well as second segment. Understand it clearly and carefully. Acknowledgement of third segment is received by or within the timeout period of third segment as well as second segment. Now what is understood by sender TCP? Sender TCP receives an acknowledgement numbered 1801. What does the sender TCP understand from that received acknowledgement? Anything and everything till byte number 1800 have been received by the receiver TCP properly. I repeat, anything and everything have been received by receiver TCP till byte number 1800 by receiving TCP. That is why it has sent the acknowledgement number 1801. Now what does it tell you? It tells you that acknowledgement of TCP is cumulative in nature. Say there are 4 segments. The third segment acknowledgement comes to sender TCP. sender TCP will understand, yes, everything has been received by receiving TCP till my third segment. What does it tell you? That tells you if the second segment is corrupt, received in corrupt manner by the receiver, third segment has been received properly, receiver must not acknowledge third segment. Why? Because if the third segment acknowledgement comes to sender, sender will understand everything till third segment has been received properly, which is not the case. So cumulative acknowledgement has advantage, it has some caveats also, or points of pondering also. That means when sender TCP gets an acknowledgement back, it understands everything has been received till the previous byte by the receiver. Receiver has to be careful enough whether to acknowledge a segment or not. That must be carefully handled by the receiver. So our discussion of error control had three different cases to discuss. One was corrupted segment, another was lost segment. These two are dealt with by TCP in a simple manner, retransmission of the segment. Third case was lost acknowledgement. If the lost acknowledgement case is dealt, or say if I get the next segment acknowledgement within the timeout of the previous segment acknowledgement timeout also, is fine. Else what would have happened? Say I get this acknowledgement within timeout of third, but second was timed out. What would have happened? I would have retransmitted the second segment. Receiver would have got a duplicate copy of that. Gets dropped. Simple. That completes our discussion on error control.